So, good afternoon, and this is a live problem solving session for basic electrical circuits E90. And this is so today, what we'll be doing is discussing the current year's assignment 3 that whose due date was there at I suppose 17th of August. Its due date was there, right? So so we will be discussing that, and after that, if time permits, we will solve a few questions of week 4, that is of the mesh analysis and all. So let's start. So again, the pattern will be same. I will please keep your pen and paper ready. I will give some time to solve the questions from your side, and after that, I will share the solution. So let's start with the first question. So here we have that a current IT is going inside a 50 millihenry inductor as shown in the figure. The waveform of the current is shown in the graph, and we
Sir,
need
have
to
you
find the.
sir, have you shared
Oh,
your screen?
sorry. Just a minute. Yeah. Wait, let me share the screen. Yeah, is my screen visible now?
Yes, sir.
Okay, so this is the question. A current of 50 a current IT is flowing into an inductor of 50 millihenry, and we need to find the energy and the power stored in the inductor at time equal to 2.5 milliseconds. And yeah, there are options in the questions, so please try to solve it first. And I hope since you guys have already submitted the assignment, so probably you can uh, just paste whatever you think is the right answer in the chat window, and in 1 or 2 minutes, we will discuss the solution. Please, whatever answer you have submitted in the assignment, or whatever you think is the correct answer, please paste it in the chat window. Okay, so fine, let's discuss the solution for this. So, what is asked is this following current is flowing into the inductor, and we need to find the energy and power stored in the inductor at time of 2.5 milliseconds. Now, we know that the power is the product of voltage and current, and for an inductor, voltage is given by the derivative of the currents multiplied by the inductance, that is equal to L di by dt. And from that, so whatever current graph we have, if we see the differential of it, so for the first part, that is the linear increase of current, the will be a slope, and then it is multiplied by the inductor value. The voltage comes out to be 200, and after that, since the current is flat, so the derivative of it is 0. Now, if you multiply the current waveform and the voltage waveform, you will get the power waveform. So power increases linearly from 0 to 800 watt till 1 milliseconds, and after that it drops to 0. Now, because the voltage is 0, and hence the power voltage, hence the voltage current product is 0. And from here at 2.5 milliseconds, the question it was asked, I suppose. Yeah, 2.5 milliseconds. So at 2.5 milliseconds, from this curve, you can see that the power that is stored in the inductor is 0. Now, area is nothing, energy is nothing but the area under the curve for the power. So, if you integrate the power waveform for 0 to 2.5 milliseconds, you will get the energy at 2.5 milliseconds. You are just to find the area of this triangle. So that comes out to be zero point 0.4 joules. Now, other way to find the energy is, you know that energy of the inductor is a half into Li square, that is half into inductance into the current square that is flowing through the inductor. So at time equal to 2.5, you can see that the current that is flowing is 4 amperes. So from there also, if you calculate, you will get the same answer of that is zero point 0.4 joules. Any doubt in this? So if there is no doubt, we'll move to the next question. So in this question, you need to find out the total power that is being absorbed by all the elements. And please try it out and paste your answers in the chat box. So here again, as we discussed previously, that you need to look carefully that in which direction the current is flowing to see whether an element is absorbing power or delivering power. So please keep in mind the convention of sign for that and try to solve this question. Okay, so let's see the solution for this. So uh, once again, I will reiterate the sign convention for this. So any element for which the current is flowing out of the positive terminal is the one that is delivering power, and any element for which the current is flowing inside the positive terminal is the one that is absorbing power. So if you see an element where the current is flowing out and the power that is being absorbed by that element is asked, so that quantity will be negative. So let's see one by one. For the 50 volts battery, the current is flowing out of the positive terminal. So the power absorbed will be V into I, and the negative of that, as it is in actual delivering the power. Now, for the 80 volts battery, the current is flowing inside the positive terminal, so it is absorbing power, and that is 560 watts. For the resistor, since it's passive element, so it will always absorb power only. It can't deliver power anytime, and the voltage that will develop will be accordingly that the in whichever terminal the current is flowing, that will become the positive terminal. So for the 10 ohm resistor, since the current is flowing is 5 ampere, so the power absorbed is I square R, that comes out to be 250 watts. Now, if you apply KCL at this node, the current that will be flowing in this direction will be of 2 amperes. And so, if 2 amperes is flowing out of the positive terminal of 20 volt battery, so the power absorbed will be minus of 40 watts. And finally, for the 4 ohm resistor, the power absorbed will be of 16 watts. So the absorbed power comes out to be 536 watts in total. I think there is some problem in the uh, options of this. So yeah, the power absorbed is 536 watts. The total power if you sum it. Any doubt in this? Okay, if there is no doubt, we'll move to the next question. So here it is asked that what is the minimum number of mesh equations that are needed to solve the circuit. So you need to find how many loops are there in the circuit, and accordingly how many mesh equations will be required. Please try it out. Okay, so uh, let's see its solution. So with the equation that you have b minus n plus 1, you will get the answer straightforward. However, you need to visualize that what all meshes are there in the system, because when you are solving it, actually you need to write the equations, and there you need to actually locate all the four meshes that that you will see in the system. Okay, so for if you observe closely, this C3 that is flowing, that is between this node and this node, this can be uh, extended and can be made like this, and this can be removed. So still the circuit will remain same. So this is what circuit looks like. So here now you can see you have four loops, hence four mesh equations you will need. Any doubt in this? So whenever the circuits are, uh, in yeah, Sandhya, do you have any doubt?
Yeah, sir. I am unable to calculate number of branch and node. B minus n plus 1 equation that is. Please help me to
So,
calculate that.
so a branches basically is equal to number of elements that you have. Or if you want to merge, you can merge these two things. So let's see. So let's point. Okay, let's do this exercise once. So you have a node over here, a node over here, then a node over here that is running all across from here. Then you have a node between C1 and C2, and finally you have a node at this point. Okay, so number of branches, if you see, mm, number of branches are one, two, three, four, five, six, seven, eight, nine. Okay, and number of nodes that you have is one, two, three, four, five, six. Okay, so branches are equal to nine, nodes are equal to six. So the number of meshes that we will have is b minus n plus 1, that comes out to be 4. Is it clear?
Sir, what about yeah, node number 2, sir? How can you take this?
So, see, that's what I said. Either you can take this complete branch as one and ignore this node. So, in that case, number of branches that you will have is 8, and the number of nodes you will have is 5. Still, the number of meshes that you will require will come same. But
Okay, sir.
what you need to actually understand is like, since this is very straightforward looking, but generally what you should prefer is you should consider each element as individual branch, so that you don't miss out in any or don't make a mistake. So yeah,
Okay, sir.
this you
Okay,
can follow.
thank you. Thank you.
Yeah. So next question we have is, uh, the current is shown, the a current waveform that is shown in the figure, that is applied to a 4 microfarad capacitor, and the initial voltage of the capacitor is given as 2 volts. And if the W1 is the energy that is stored in the capacitor over the interval of 0 to 2 milliseconds, and W2 is the energy stored in the capacitor for 2 to 3 milliseconds. So you need to find the values of W1 and W2. So please try it out, and after some time we will discuss the solution. Okay, so let's see the solution for this. Now, current has been given to you, and you know that the voltage that and the energy can be calculated as half times C times V square for a capacitor, and the voltage you have is 1 by C integral of I dt. Okay, so, like over time 2 milliseconds, the total current that total voltage, additional voltage that will appear on the capacitor can be calculated by the area of this triangle. And if you calculate the area, that comes out to be basically uh, if you calculate the area, it comes out to be 2 milliamperes into 2 milliseconds into 1 by 2 divided by the capacitance value, that is 4 microfarad, and that comes out to be zero point 0.5 volts. However, since initial voltage was there of 2 volts on the capacitor, so the voltage at 2 milliseconds will be 2.5 volts, and at 3 milliseconds, the additional voltage that will accumulate on the capacitor is the area under this rectangle, and that is of 1 volt. So, sorry, zero point 0.5 volts again. That is 1 by 4 microfarad into 2 milliamps into 1 millisecond. So this also comes out to be zero point 0.5 volt, and the total voltage becomes 3 volts. Now, you have been asked that what is the energy that is stored in the interval 0 to 2 milliseconds and 2 to 3 milliseconds. So you need to calculate the energy at the starting of the interval and energy at the end of the interval and subtract it. So if you do that for W1, you get as 4.5 microjoules, and W2 you get as 5.5 microjoules. So yeah, this is it. And please keep in mind, since the energy is proportional to V square. So if you are thinking that, okay, I will take the whatever additional voltage that has been accumulated on the capacitor, and I will calculate delta V square, half times C delta V square. So you will end up with the wrong answer. So please make sure that you need to calculate the voltage at each at the starting, at the end of the interval, and then subtract the energies of the two to get the correct answer. Any doubt in this? So if there is no doubt, we'll move to the next question. Now, so in this question, you need to find the power that is absorbed by this 200 milliohm resistor. And for that, basically, you need to find the current that is flowing through this resistor, and then, yeah, I square R will be the power. So please try it out once. Okay, so let's solve this question. So, one straightforward way and a straightforward and tedious way is to solve it with the help of either nodal analysis or mesh analysis. So here I have presented the example of nodal analysis. So one node you can take as the reference node and consider it as 0 volts, and other nodes are N1, N2, and N3 that you can consider. And at each node you can write the KCL, and once you write the KCL, you will have three voltages, that is V1, V2, and V3 of the three nodes, and three equations. Now solve it. Once you get the voltage V2, basically V2 minus the 10 volt that you have will give you the current across it, and then you find the power. Now, this is a very tedious way of solving this. However, can you guys see any symmetry in the circuit that can be exploited to solve this question quickly? Uh, can anyone see it? Please try to search it if uh, anyone can see this. Okay, so if you see this branch, so we have a node over here and one node over here. So if you see that if you try to redraw the circuit, how you can redraw it is in the following way. So this node over here can be redrawn as this thing, and this node over here can be redrawn at this point. So you will get a Wheatstone bridge kind of a structure over here, that 6 ohms, 6 ohms, and 4 ohms, 4 ohms. So these two voltages will become same in that case, and since these two voltages are same, so this resistor can be ignored as the current flowing through it will be zero. So from there, if you calculate it, the total parallel resistance comes out to be 4.8 ohms, and the total resistance as this 10 volt will see is of 5 ohms. So the current that will be flowing through this voltage source, and hence the 200 milliohm resistor comes out to be 2 amperes, and the power you can find out as I square R, that comes out to be point 0.8 watts. So if you can find these kind of symmetries in the circuit, which will come after a lot of practice, then you can save a lot of time and effort to solve these kind of questions. So yeah, please solve as many questions as possible, and you will uh, be able to see these kind of symmetries, because in gate, since you have to solve you have to solve 65 questions in a limited amount of time. So most of the questions have these kind of shortcuts, you can say, and you need to keep your eyes open to uh, identify it. Otherwise, you will end up wasting a lot of time in doing things in conventional way. However, try to solve things conventionally first, and once you are confident about it, then try to look for symmetries and all. So yeah, the only way to do it with a lot of practice. So okay, now let's come to this question. So you need to find in this capacitor network that is given to you, you need to find the energy that is stored on 200 millifarad capacitor. So please try it out. So, sorry for the disturbance. Now, let's see how to solve this question. So, you need to find the energy stored in this 200 millifarad capacitor, and for that, basically CV square, half CV square. And first of all, this complete capacitor can be taken as 30 millifarad capacitor. Now, let's see. So we have, in this case, we have three capacitors in parallel, and we need to find voltage across one of the capacitors. So let's see the general case, how we can find if we have multiple capacitors in series. And sorry, I meant series in the starting also. So if we have multiple capacitors in series, so in that case, how to find out the voltage across one of the capacitor. So for this, what you should consider is that the charge that is stored in each of the capacitor in case of a series combination of capacitor is same. And you know that in series, the equivalent capacitance that you get is summation of reciprocal of all the capacitance. The charge that is stored across the equivalent capacitor, that is the CEQ. So this will be equal to so the total charge will be equal to CEQ times the applied voltage. And again, since the charge is same in the series, so that will also be equal to the kth capacitor and the voltage across the kth capacitor. So if you equate these two, from here you will get the value of the voltage across the kth capacitor as Vk is equal to Ceq by Ck times the total voltage that is applied across the capacitor. So that comes out to be 1 by Ck divided by the summation of reciprocal of all the capacitance times the total voltage that is applied. Now, if you apply this, so this is one of the formula that you can remember for quick calculations. And so if you apply this in the circuit that is of interest to us, so in that case, you will get the value of V3, that is across the 30 millifarad capacitor, as 5 volts. And from there, you can find out. And since the 20 millifarad capacitor and 10 millifarad capacitors are in parallel, so the voltage V3 will be same across both the two capacitors. So from there, the energy is there as half times C times V square. So that comes out to be 250 millijoules. So yeah, any doubt in this?
So what about that? How in generally we read that the मतलब कि हम जहाँ कैलकुलेट करते हैं उसके क्रॉस
Hmm.
अगर हमको निकालना होता है तो हम उस पे अप्लाई नहीं करते हैं सर कि जैसे इस दोनों को अगर सीरीज हम कैलकुलेट कर लिए इस दोनों कैपेसिटर को ऐड कर दिए तो फिर यहाँ पर सेम वोल्टेज कैसे होगा सॉरी
नहीं वो जब ये पैरेलल में so you can understand in English, right? Because there are few people that
यस सर या
yeah. So what she's asking is that how the voltage across this the two capacitors will be same. Is this what you what your doubt is?
या
Yeah, so if you see from the physical means, if you see, so what is this case is what is capacitor? C is equal to epsilon times A divided by the distance between the plates, right?
या
Parallel plate capacitance formula, you know, right? Now let's see it in 3D over here. So let's say you have one capacitor as this. With some dielectric between this, and so this is one capacitor, and in parallel to it, uh, So in parallel to this, one more capacitor is present. Uh, so so these two capacitors are present in parallel to each other. Okay. Now, what will be the total capacitance that you will see? That will be the total area of these two plates, right? So let's call this plate as A1, and let's call the area of this plate as A1, and the area of next plate as A2. So total capacitance will be epsilon A1 plus A2 by D. Okay. So this can also be written as epsilon A1 by D plus epsilon A2 by D. Okay, so like these can be written as sum of two individual capacitance also, and the total area that is there of the combined plates can be written as A1 plus A2. Now the voltage, if you apply across this, so uh, let's say we apply voltage source across this. So both the plates, what they will see is so at the negative plate, both of them will see 0 volt, and at the positive plate, both of them will see plus V volts. So that's why the if you consider it as two different capacitor, or if you consider it as a complete capacitor of value epsilon A1 plus A2 by D. So in all the cases, the voltage that you are applying across it is same. So that's why, once you calculate the voltage of this combined effect, that will be same that each of the capacitors will see. Now, what you can even further do is you can break this one capacitor also in multiple slits, and you will have many other many small capacitors, and each of the capacitors will see the same voltage. However, since you need to find the energy stored on one particular capacitor, so in that case, what you need to do is so what is basically the energy? The energy is so if you see it in form of charge, it will be a little easier. So in form of charge, the energy is q square 2 by c, right? Uh, am I correct? Yeah. In charge form, the energy is Q square 2 by C, or in voltage form, it's CV square by 2. So, if you, let's say, remove one portion of this capacitor and consider it as an individual capacitor, so this will have a certain amount of charge that is proportional to whatever area that it has. That is basically, again, it is proportional to whatever capacitance it has. So yeah, so once, and since the voltage that all these individual capacitors are seeing is same, so basically for finding the energy, the voltage you can use whatever is common voltage for all of these, and that you can multiply with whatever that individual element of capacitance is there, and yeah, from there you can find the energy. So yeah, uh, does this explains your doubt?
Yes, sir. Yeah, complete. Okay, thank you.
Okay, so now in this question, you need to find out. There is a inductor that is in which two currents are one of the current source is pushing in the current, and other is pulling out the current, and the waveforms of both the currents are given, and you need to find the voltage that is developed across the inductor at 3.5 seconds and 5 seconds. So please try it out once. Okay, so let's see. Let's say we consider the current. So we need to find this voltage VT across the inductor, and since inductor again is a passive element, so the current that will be considering will be in the direction that that will be going inside the positive terminal. So IL basically is equal to I1. That is, so if you apply KCL at this node, so in this case, the IL will be equal to I1 minus I2. So the graph of I1 and I2 are given to you. So in for the time interval of 0 to 2 seconds, you can see that I1 is increasing at 1 ampere per second. That is at 3 seconds it is going to 3 amperes. At 2 seconds it will go to 2 amperes. So it is increasing at 1 ampere per second, and I2 is increasing at 2 amperes per second. So I1 minus I2 will decrease at 2 amperes per second. So the slope will be minus 2 ampere per second till 2 volt till 2 seconds. After that, there is a sudden jump in the I2, and this jump is basically negative. And since I2 is being subtracted, so in I1 minus I2, this jump will look as positive, and the jump is of 4 amperes. So from minus 2 this will go to plus 2 amperes, and after that for time interval 2 to 4, the I2 is 0. So whatever the value of I1 you have will come right away into the IL equation. So this portion of I1 will be copied at over in the IL equation, and and after that there is again a sudden positive jump of so this time the jump is positive in case of I2. So in I1 minus I2, the jump will be negative. So from 2 amperes, it will go to minus 2 amperes. And after that, again, the I1 is decreasing at 1 ampere per second, and I2 is decreasing at 2 amperes per second. So I1 minus I2 will increase at 2 amperes per second. So you will get this over. Now, since inductor's voltage is related as V is equal to L di by dt, so what you need to do is you need to find the slopes of these individual piecewise linear curves, and and that you multiply with the value of inductance. So from there you get the voltages, and once you get the voltages, you are asked the voltage as 3.5 seconds. 3.5 seconds lies somewhere over here, and that will be equal to minus 2 volts, and at 5 seconds it will be equal to plus 2 volts. So any doubt in this? Okay, so let's move forward. So here there is a square wave generator that produces the voltage that is given as VT, and when this voltage is applied across an element, you get a current that is triangular in nature. So here you need to first of all tell what kind of element it is, and after that what is the energy that is stored in the element at 1.5 milliseconds, that you need to find, and you can assume that initially that element is uncharged. So please try it out. Okay, so let's see the solution for this. Now, you can see that the relation between voltage and current is such that the voltage is being integrated since the current is a square wave and the voltage is the square wave and current is a triangular wave. That means the voltage is being integrated through the element to get the current. Now, like which element does the integration is the inductor. So for inductor, current and voltage are related through this equation that I is equal to 1 by L times V dt. Hence, the element is inductor. Now, so you need to find the energy stored in the element at 1.5 milliseconds. So for t less than 1.5 millisecond. Yeah, correct. So for this portion of time, the slope with which it is reducing is of 2 amperes per millisecond. So at 1.5 millisecond, it will be exactly midway, and that will be 2 amperes. So from there, using half Li square, you can find the value of the energy stored. So yeah, that comes out to be 2.5 millijoules. Actually, the question has values in joules, so I think this is some inconsistency. So yeah, any doubt in this? Okay, so let's move forward. So here, what you need to do is you have been given that there is a current source that is pumping current into this resistive network, and it is given that when this current source pumps a value of current I naught, then the voltage V that is developed across 1 ohm resistor is 1 volt. And it is asked that what will be the power dissipated across the 4 ohm resistor if this current is doubled, that is, it is increased to a value of 2 I naught. So, this please try it out. So, in this question, what we need to understand is that first of all, since the voltage across this 1 ohm resistor is given as 1 volt, so the current that will be flowing will be of 1 ampere. And if 1 ampere flows through this 2 ohm and 1 ohm in series, so the voltage developed will be 3 volt. And since the 6 ohm is in parallel with this 3 ohm equivalent resistance, so the voltage developed across this will also be equal to 3 volts. Hence, the current that will be flowing will be of zero point 0.5 ampere. So, applying KCL at this node, you will get value of current that is flowing through 4 ohm resistor is as 1.5 amperes. Now, this is the case when the current that is flowing is of I naught. Now, since it is a linear circuit, so principle of homogeneity will be applicable. So, if you double the current that is being pumped into the circuit, the currents and voltages of each node will also double. So, since earlier the current was flowing I naught, so in that case, 1.5 ampere current was flowing through 4 ohm resistor. Now, this current will double to 3 ampere current. And so, then after that, to calculate the power, it is I square R, and I square R comes out to be 36 watts. Any doubt in this? Okay, so let's move to the next question. Yeah.
Sir, please explain the homogeneity principle.
So, any linear circuit that you come across, any linear system. Have you guys studied signals and system?
Yeah, sir.
Yeah. So there, you might have studied that a linear system will follow two principles. One is the principle of homogeneity. The principle will be homogeneous. and other is uh, I'm sorry, I'm not very good with the spellings. Okay, so one is the principle will be homogeneous, and other is that principle will follow the principle of the system will follow the principle of superposition. So now, what homogeneous means is that if y is a function of x as and is related by y is equal to fx. So in this case, if x is changed to some alpha x, in that case y will become alpha times f of x. Sorry, f of x. So this basically what this principle means is that the alpha that is in the argument can be pulled out and can be multiplied with the function itself. So that is what is happening in this case. Like since it is a completely resistive system, so I naught. So the current in branch with current in 4 ohm branch will let's say we call it I4 will be related to I naught with a constant that is let's say some k multiplied by some I naught. So this function is a homogeneous function. So in this case, if I naught is increased by I naught is doubled, so I4 will also double. So basically here alpha is 2. So this is what the homogeneity principle is. Now for a linear system, you need to make sure that both homogeneity and superposition are valid, because there might be case where the system in actual is non-linear, but superposition is still valid. So you need to look out for that. Uh, yeah. Any doubt in this? So does it clear your doubts, Sandhya?
Yeah.
Okay. So let's move to next question. So here, what you have been given is that there is this complete network that contains two resistors RA, RB, and the sum of two resistance is 500 ohms. And there is additional circuit X that is connected in parallel with RB. And it is mentioned that the value of RB is adjusted such that the current IX that is flowing inside the circuit X is zero point 0.1 ampere, and the voltage that is developed across this circuit is of 25 volts. Then you need to find the total power that this 200 volt voltage source will be dissipating. So please try it out. Okay, so let's see its solution. So what you need to first of all see is that this 200 volt is across the RA and RB. So the voltages VRA and VRB, if you sum, basically apply the mesh equation in this loop, will be equal to 200 volts, and VRA is nothing but equal to Vx, So VRB is nothing but equal to Vx, and that is of 25 volts, and hence the VRA comes out to be 175 volts. Now, other thing is that the total current IT that flows from 200 volt will be the zero point 0.1 ampere that is flowing into circuit X, and the current that will be flowing into the resistance RB. So that will be zero point 0.1 ampere plus the voltage developed, that is 25 divided by RB, and that is also since this current and the total current that is flowing like in RA and RB are same. So this will also be equal to 175 volt that is across RA divided by RA. And since in the question it is given that RA plus RB is 500 ohms, so RA you can write as 500 minus RB. So if you solve this question, you will get a quadratic equation in RB. So when you try to solve it, you get the value of RB as 79.156 ohms, and RA you get as 420.843 ohms. So the total current will be VA by RA, that is 175 by 420.84 ohms, and that comes out to be 0.4158 amperes. And the power that will that this 200 volt voltage source will be supplying is voltage, that is 200 volt multiplied by RT. So that comes out to be 83.166 watts. Any doubt in this? Okay, so let's move to this question. Now, again, this circuit is linear, that is given to you, and two current sources, that is I1 and I2, are pumping current into this, and at one of the nodes, voltage V is being developed, and the two sets of values of I1, I2, and V is given to you, and you need to find the value of V for another set of I1 and I2. So, in this case, as I mentioned earlier, that since a linear system has two principles, that is homogeneity and superposition. So here the principle of superposition will be applied. So let's say only I1 was flowing and I2 was zero. So the voltage would have been some K1 times I1. And when I2 was flowing and I1 was zero, the voltage would have been some K2 times I2. And when both the currents are flowing, so the voltage will be K1, the sum of the two, that is K1 I1 plus K2 I2. The first set is given as that 80 volt current voltage is developed when current I1 is 8 amperes and current I2 is 12 amperes. So from there you get another one equation, and from another set of currents and voltages you get another equation. So you have two variables and two equations. When you solve it, you get K2 as 5 and K1 as 2.5. So from there, for the third set of I1 and I2, you can find the voltage, and that comes out to be 150 volts. Any doubt in this? Okay, so so these were the questions of the current assignment that you guys needed to submit by 17th of August. And now let's look at one more question that is pertaining to this week. So, and then we will conclude the session. So here, what you there is this network that is there in the question, and what you need to do is you need to find the voltage difference between the node VA and the node VC. Please try it out. Okay, so let's see how to solve this. So you need to find the voltage difference from across this path. So uh, how you will find it is the following. Now, what you need to do over here is you keep on calculating the voltage from node VA to VC. So that comes out to be VA plus since this is adding this voltage source is adding voltage, so that is plus 4 volts minus 3 times I3 minus 1 times I1, and that equals VC. So VA minus VC comes out to be 4 minus 3 I3 minus 1 I1. Now if you see these two meshes are there, so let's say 1 milliampere current is flowing in this direction. So since this is complete a closed loop, so what will happen is 1 milliampere current will be flowing through 1 kilo ohm resistor also. So 1 milliampere flows in this direction, and 1 milliampere flows in this direction. So current that is flowing in this direction will be zero. Okay, so the value of I3 will be equal to 0, and since value of I3 equal to 0, so this term can be neglected, and then again for this node, this mesh, what you will have to do is so 1 kilo ohm, 1 kilo ohm, 2 kilo ohm, so total 4 kilo ohm resistor is there, and that is being a 3 volt voltage source is supplying current to it. So the I1 comes out to be 3 by 4, that is 0.75, and so the voltage that comes out to be 4 minus 1 I1, so it is 4 minus 0.75, not plus. So I think one of you guys wrote answer as 4.75, so it's 4 minus 0.75, that comes out to be 3.25. Any doubt in this? Okay, so yeah, this was yeah.
Yeah, sir. About polarity of BA. What is the polar? How can we take the polarity?
Uh, See, polarity you can check for uh, a potential difference for the for a particular voltage and absolute voltage, unless and until you are not given a reference node, you can't comment about the polarity of that particular node's voltage. Let's say I am giving let's say this particular node as the reference node. So after that, you can say that with respect to that reference node, whether that one branch is positive or negative. However, if like that reference node is not given, then you can't find the polarity of voltages of each individual nodes.
So what about
So
polarity of BA? How can we find that it is positive or negative? BA, BB and BC. I am
that's what
talking
I'm
about,
saying.
yeah.
So VA, VB, and VC are voltages of individual nodes. They are not voltages, potential differences. So voltages of individual nodes, you can't find the polarity unless and until a reference node voltage and reference node is not given. So if let's say a reference node is given and said that okay, consider this voltage as zero, after that you can find the polarity of each of the nodes. That's why in the question the VA minus VC is being asked, and not absolute VA or VB or VC, that you cannot find.
Okay, okay. Okay, thank you, sir.
Yeah. So any other doubts? So if there is no other doubt, so this was it from my side, and this concludes this session. So thank you for attending.
Thank you, sir.